Hi everyone, I am Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Engineering. In previous videos, we saw about what is asymptotic notations, big O notation, and omega notations. In this video, we are going to see about what is theta notation in design and analysis of algorithm subject. General definition of Big-Theta notation is a function f of n is said to be in theta of g of n, denoted f of n belongs to theta of g of n. If f of n is bounded both above and below by some positive constant multiples of g of n for all large n, that is, if there exist some positive constants c1 and c2 and n non-negative integer n0 such that c2 of g of n is less than or equal to f of n, less than or equal to c1 of f of g of n for all n is greater than or equal to 0. This is defined in graphical representation also. See, the function f of n is lies in between c1 of g of n and c2 of g of n. So that is, theta notation always lies between average bound of the notations. G of n is asymptotically tied bound for f of n. So, in the slide, definition for upward bound notation. For f of n is big O of g of n, if there exist positive constants c and n naught such that f of n is less than or equal to c into g of n for all n greater than or equal to n naught. Formally, big O of g of n is equal to f of n for all positive constants c and n naught such that f of n is less than or equal to c into g of n for all n is greater than or equal to n naught. Here, a big O factor, a polynomial of degree k is big O of n power k. An asymptotically lower bound, that is omega notation. If f of n is omega of g of n, if there exist some positive constants c and n naught such that 0 greater than less than equal to c into g of n less than equal to f of n for all n greater than equal to n naught. Asymptotically tied bound, it means this is for theta notation. Here f of n is theta of g of n if there exist some positive constants c1, c2 and n naught such that c1 into g of n less than or equal to f of n less than or equal to c2 into g of n for all n greater than or equal to 0. Here f of n is equal to omega of g of n if and only if f of n is equal to big O of g of n and f of n is equal to omega of g of n. See, this is the relation between this is the graphical relationship between omega theta, big O and omega. In theta notation, the function f of n is a tied bound. Both it lies between upper bound and lower bound. It is also known as average bound. And then second graph is for big O of g of n, that is for worst case complexity. This is the upper bound of the function, and the last omega is the lower bound of the function. And big O notation for a given function g of n, the set little o, here O of g of n is equal to f of n for all c is greater than 0. For there exists n naught is greater than 0 such that for all n greater than equal to n naught we have 0 less than or equal to f of n less than or equal to c into g of n. So here f of n becomes insignificant relative to g of n as n approaches infinity, that is limit n turns to infinity. So f of n by g of n is equal to 0. Here g of n is the upper bound for f of n. This is not asymptotically tight. So these are the types of asymptotic notation. We saw about a big O. big omega, big theta and little o notations. And omega notation, little omega notation for a given function g of n, the set little omega, omega of g of n is equal to f of n for all c is greater than 0. There exists some n naught is greater than 0 such that for all n greater than equal to n naught we have a 0 less than or equal to c of g of n less than or equal to f of n. Here f of n becomes arbitrarily large relative to g of n as n approaches infinity, and limit n turns to infinity, f of n by g of n is equal to infinity. Here g of n is a lower bound for f of n. This is not asymptotically tight one. So these are the 5 types of asymptotic notations. This is the comparison of function. Here f turns to g and are equal to a turns to b. These are the 5 functions of asymptotic notations: big O, omega, theta, little o and little omega. Thank you.